So what if the divisor is a trinomial? It doesn't actually make a difference. So whatever you're dividing by, as long as it's a polynomial, you're going to do it the exact same way. So once again, first term divided by first term. So x to the 4 divided by x squared, you get x squared. So I'm just going to line up my x squareds again. And then you take that first part of the quotient, multiply it by the entire divisor. You're going to multiply it by all three terms. So x squared times x squared is x to the 4. X squared times 3x, 3x cubed. X squared times minus 2, negative 2x squared. Okay, and then just like before, you will subtract. So subtracting all these terms, we end up with 2x cubed plus x squared, and then you bring down the next term. Because we're dealing with a trinomial, you do need to make sure that you have three terms down here, but that's really the only difference. Because when it was binomial, you only needed two terms. And then we begin the process all over again. So we take our 2x cubed, divide it by the first term of the divisor. So 2x cubed divided by x squared is 2x. Okay. Take the 2x, multiply it by all three terms. And then we subtract. Okay, subtracting the first term goes away. X squared minus 6, negative 5x squared, 7 minus negative 4. There we have 11x. And then we bring down the next term and begin the process all over again. Negative 5x squared divided by x squared gets us a negative 5. Take that negative 5, multiply it by all three terms. We get negative 5x squared minus 15x plus 10, and then we subtract. And when we subtract this, we will get 26x minus 11. And usually you would have kept going, except if you tried to take 26x and divide it by x squared, it doesn't divide in. Okay? And that's because the remainder is a lower degree than our divisor. So this is the remainder. Okay, sometimes it will be a constant term, but it can also be a degree 1 term, since our divisor was degree 2. Okay. So if I want to write this out, I can write it as the dividend equals the divisor times the quotient plus that remainder. And if you were going to find the restriction for this, you actually have to figure out what makes that divisor 0. Okay, because remember, the divisor can't equal 0 if we're dividing by it. So to find the restrictions, it is a little bit more work in this case, because we have to set the divisor equal to 0 and solve. And in this case, you would have to solve using the quadratic formula since your divisor is a quadratic. So here's our next example. When a polynomial f of x is divided by x minus 1, the quotient is x squared plus 6x, and the remainder is 4. Find f of x. Okay, so they're telling you f of x is your dividend, because that's what you're dividing. It's divided by x minus 1, so that is your divisor. They give you the quotient and they give you the remainder. So if you take that pattern that dividend equals quotient times divisor plus remainder, and you just sub everything in, for a dividend we're going to sub in f of x. Our quotient, we will substitute in x squared plus 6x. Our divisor, we put in x minus 1, and the remainder is 4. Okay. And then if we expand this out and simplify, we get that f at x is equal to x cubed plus 5x squared minus 6x plus 4. Okay, and there is our polynomial. The last thing we're going to do today is we're going to talk about synthetic division. So synthetic division is the second way of doing polynomial division. It is faster, and it is the way that I recommend using. Okay, it doesn't work for all cases. Okay, so synthetic division is what we're going to use whenever we are dividing by x plus or minus some number. So for example, x minus 2, if we're dividing by that, we can use synthetic. X plus 5, x plus 15 million, x minus 32,000. Okay, as long as it's x plus or minus some number, synthetic division is going to be what you want to use because it is quicker and it's a lot less writing. So we're going to go through how you do synthetic division. So if we were dividing this cubic by x minus 3, the way we do synthetic division is we first start by only taking the coefficients. Okay? You need to make sure that every single term has a coefficient. So if you're missing a term, like missing your x squared, you'd have to put a 0 as the coefficient. So we have a 2 for the x cubed, so that's why we have a 2 down here. We have a negative 7 for the x squared, so that goes next. X is 6, that went next. And then constant, negative 4, and that's why we have a negative 4 there. So that's where we got that top line. It's just by taking the coefficients and writing them out. Okay? And then this 3 we get by looking at our divisor and thinking, what would have been the root? What would make that 0? A 3 would make it 0, so we place a 3 right here. Okay? And then we would have drawn this line. And that's how we would have started doing synthetic division. Okay? And then what we're going to do next is we always just pull down the first number and write it below the line. And then our next step is always multiply by whatever the number is on the left side here. So in our case, it's a 3. So we're going to multiply by 3. 2 times 3. That's how I got the 6. And then our next step is always add the column. So negative 7 plus 6. That's how I got this negative 1. And then we repeat the process all over again. So we multiply to get up, so times 3, negative 1 times 3, that was the negative 3. Add the column. That's how I got that 3 there. Okay, then same thing all over again. Multiply up, so times 3. Add the column. That's how I got the 5. And then we're actually done the division. We can just read off of our answer. The way we read our answer here is it's this bottom row. Whatever the last number is, that is always your remainder. The next number will always be your constant term. The next number will always be your x term. The next number will always be your x squared term. And then it would continue. If there's another term, it would be your x cubed. If there's another term, it would be your x to the 4. So the quotient here is 2x squared, which we got, minus x, which we have there, plus 3, with a remainder of 5. So that might not have made sense, but we'll do an example from scratch next. So here they're telling us to use synthetic division to divide our dividend by the divisor of x plus 2. Okay, so we're going to start by taking all the coefficients and writing them up at the top here. So we have a 1, a 5, -2, and -9. And our divisor is x plus 2. So what would make that 0 would be a -2. So I'm going to write -2 there. So that's our starting point. And now we follow the exact same pattern. We always add down. Okay, since there's nothing in the first column, then it just ends up being the 1. And then multiply up. So when I want to move up, I have to multiply by this -2. So 1 times -2, -2. Okay, and then same thing all over again. Add down, so 5 plus -2, 3. Multiply by the -2, -6. Add down, -8. Multiply by the -2, 16. Add down, 7. And there's no more steps here, so we're done. The 7 would be the remainder. The 8 will be a constant term. The 3 will be our x term. And the 1 would be our x squared term. So the quotient here is 1x squared plus 3x minus 8, and there is a remainder of 7. Okay, so hopefully you can see that is a lot quicker than if you did long division for polynomials. Okay, it also takes up a lot less space on your paper, so strongly recommended that you use synthetic division where you can. Okay, and we will be using synthetic division a lot. So you want to write as little as possible, and it also gives you less room for error. Okay, and it's really easy to check your work. And the little note here at the end is what I talked about at the beginning when we introduced synthetic division. You're only going to use synthetic division when you're dividing by a binomial whose leading coefficient is 1. Okay, so that's x plus or minus a number. You would have to use long division whenever you're dividing by anything else. So if you're dividing by 2x plus 14, I would recommend using long division. If you're dividing by x squared minus 1, use long division. Okay, if you're dividing by x cubed plus 4x minus 1, you're going to use long division. Okay, so synthetic division is only when it is x plus or minus a number. So that's the end of the lesson, so you guys can give the homework a try now.